Another gratuitous plug. Remember, Irrational Labs is a consultancy. We like help companies and stuff. But seriously, we work in almost every vertical imaginable. This is our consulting page. You know, we work in product design, research and prototyping, marketing and growth, employee engagement, employee wellness. We do speaking engagements. We'll do ethics training for employees, especially unethical ones. And there's all kinds of custom jazz that we do for you. And last but not least, if you're a member, but you're not in the boot camp, get with it. The boot camp's rad. Come on, join, have some fun. It is great fun here. We have 3 different courses that we offer. We have kind of the general behavioral design course. We have a financial specialization and a health specialization. Most popular questions you ask, what's the difference between the 3? Oh, I'm so glad you rhetorically asked me. The behavioral design course is kind of the basics, and it touches on almost every vertical. And it also gives you the greatest hits in the field. Behavioral design with the finance specialization, the case studies are mostly finance, and the same goes for health. So they're very similar. I mean, you get the same psychological concepts for the most part, but if you need to dive deeper into like, what does this look like in fintech? What does this look like in health tech? We are here for you. And speaking of being here for you, oh my gosh, ladies and gentlemen, I think, Karl, now you're a senior behavioral scientist. That's like, you've graduated from being a freshman, sophomore, and junior to a straight up senior. Karl is amazing. I don't have his bio handy, but let me tell you a little bit about him. First of all, he's not from the US. You'll be able to tell by his accent. It's a northern country. Bonus points if anyone puts the flag emoji. First person that puts the flag emoji in the chat when he speaks gets absolutely nothing but the pride of knowing that you can tell accents really well. His master's degree in behavioral economics from, I believe, Sterling University, correct? And oh snap, that's no fun. I ruined it. Sterling, but that was in the UK. Sterling's in the UK, right?
That's right, in Scotland, yeah.
Yeah, in Scotland, right. Okay, so I could have actually not blown it. Oh well. Anyways, there's still no prize if you put the emoji in. But Sterling in Scotland, and he's done a lot of incredible stuff, but the most incredible thing was Karl just like went to the Irish government, was like, hey, it went exactly like this, by the way. He's like, hey, we need a behavioral design unit. And they were like, okay, Karl, 20-year-old wonderkind. No, he wasn't 20, but he did build out the first behavioral science unit for the government of Ireland. And now he's working for our company, living in San Diego. You can tell he's got such an intense tan. Karl, take it away. Let's learn about this AI thing with you.
All right, thanks, Ryan. Thank you very much for the nice and kind introduction, as always. And yeah, I think 1 or 2 people have guessed that I was from Scotland and from Canada, but Ryan really gave it away. I'm originally from Ireland. So yeah, I set up the first behavioral economics team there. And I think it was actually in my 20s, now that I think about it. But it definitely wasn't as easy as Ryan made it seem. I wish it had been. That would have been a much smoother ride. So today, I'm going to talk a little bit about 3 ways AI will change behavioral design, but there's a little bit of a path to get there. I'll tell you a little bit about who I am, give you some more details about why I should even be talking on this topic. We'll talk about what actually is AI. I think it's one of those terms that's thrown around a lot and people have very different conceptions of what it means. We'll also talk about the important element of using AI responsibly and ethically. And we will take questions then after that on any and all topics related to behavioral design and AI. So with that, let's jump in. So I work for Irrational Labs. As you probably all know, we were co-founded by Dan Ariely and Kristen Berman, and we have great managing directors in Evelyn and Richard. And since joining, I've been lucky to work on some of these big names that you see in front of you, but Irrational Labs has a lot of experience across big tech, health, and indeed government. And so since I've joined, I've done some projects with Microsoft, I've done some project with the US Department of Labor, and also with TikTok. But to give you a little bit more concrete details a bit about myself, I am a senior behavioral scientist, as Ryan said. Hopefully that refers to the level of knowledge I've picked up over the years, rather than just the number of years I've picked up over the years. I do have a couple of grades coming in.
No, but you've been starting quite a bit. You moved up from JV to varsity, as we'd say here in the States.
That's right. That's right. And so as part of my work with Irrational Labs, one of the reasons I love working here is we routinely get to work with Fortune 500 companies where we design kind of clever experiments and diagnose either user interfaces or parts of products or processes to try and solve major problems for these clients and their users, right? The sweet spot is when we find a client who's working on a problem that's really important to solve, both for them, but also to improve the welfare of their clients. So whether that's in fintech, trying to help people save more, or whether that's with large platforms like TikTok, trying to reduce the sharing of misinformation. That's one part of my job that I really enjoy, getting to work on these complicated problems. As Ryan said, I started one of the, if not the first, behavioral economics team in Ireland that I led for about 4 years. So ran a large number of policy experiments there, mostly trying to understand how to change people's energy behavior. So how to do things like get people to purchase an electric vehicle or install a heat pump in their home instead of a gas boiler. Doesn't sound super sexy and interesting, but they were really meaty problems and super important when we're tackling big problems like climate change. And so I was very lucky to get to lead that team for about 4 years. In 2020, when the COVID pandemic hit, I was asked to advise the Irish government on COVID policy, particularly about how to encourage people to do things like get vaccinated if they were willing to do so, and to engage in protective behaviors like masking and social distancing. And 2020 was a crazy year for me, I'm sure as it was for everyone, because I was basically doing 3 full-time jobs all at once. I was leading the team at the Sustainable Energy Authority, I was advising the government on COVID policy, and I was studying for my higher diploma in science in data analytics, where I did my thesis using a machine learning approach to try and predict electric vehicle adoption. So 2020, 2021 are pretty much a blur for me, as I'm sure they are for a lot of people, and less so because I was at home enjoying fine bottles of wine every night, and more so because I just had an incredible amount of stuff I was trying to get through at the time. All right, so that's enough about, or go ahead, Ryan.
No, it's just like, I'm just picturing you drinking wine through COVID, doing your dissertation, advising governments. It was just a ridiculously silly image, Karl. Thank you. And it would have been great. You should have had a wine glass on tap so you'd pull that up and be like, and now I feel a little more mellow. Let me talk about AI.
I mean, my wife is a wine buyer, so there definitely was a few nice bottles of wine consumed that year as well to get through it like everyone else. To talk a little bit more about kind of my background in machine learning and artificial intelligence, I'll tell you a little bit about my thesis. So what I'm showing you here are 2 different maps. The one on the right is if you tried to plot basically everywhere in Ireland where someone had purchased an electric vehicle, you would get the plot on the right. And on the left is a map that I created after building a machine learning model, an AI model if you want, that tried to predict electric vehicle uptake using information from the census and using data that we had at the Energy Authority. And so I was kind of combining factors like a household's income, what's their typical commute distance, what's the gender of the head of the household, all of these different things, feeding that into a machine learning model and using that to predict electric vehicle uptake. And as you can see, thankfully, my thesis turned out pretty well, and I managed to get pretty close to what actual electric vehicle uptake looked like. So I think an accuracy of over 90%. So it was really effective at doing so. And so that's just to convince you that I know a little bit about what I'm talking about when we talk about AI. Like everyone, I think it's important to acknowledge that AI is a super, super complicated topic, and it's very deep. I'm not a machine learning expert by any standard, but I do have some experience in this area. All right, and with that, now that I've just admitted that, let me define AI. But I think more interestingly, how about everyone take a shot at this in the chat? What, if I say the words AI, or if I say artificial intelligence to you, what does that mean to you? How would you define it? I know this is a really fun and easy task to do in like 5 words or less. Let's see.
Evan did one. Evan's was pretty funny.
Yeah, that definitely comes to mind for a lot of people. Terminator. Using machine learning to predict or prescript an outcome. Yeah, absolutely. Improving productivity and efficiency. Yes, and we'll talk about that. The movie Her. Absolutely. ChatGPT, right? Automation, programmatic learning, robot takeover, Alexa, Minority Report. Yeah, I think this is exactly why I wanted to start this talk with this definition, is we all have different kind of mental models of what AI is and, you know, what the outcomes of greater and greater AI is likely to be. But really simply put, this is like the simplest definition I could find, is that artificial intelligence is just the ability of a computer or a computer-controlled robot to perform tasks that are commonly associated with intelligent beings. So if we see a task and we say, you know, yeah, you want to hire someone who's like halfway reasonably intelligent to do that task, and then a computer can achieve it, we're basically calling that artificial intelligence, right? But let's get a little bit more detailed, a little bit more nuanced, because like any kind of fast-growing industry where there's a lot of hype, we also get a lot of jargon at the same time. So you've probably heard these different words being thrown about at different times, right? AI, machine learning, large language models, what are these things? And the way I like to think about it is they're all nested within each other. So artificial intelligence is like what you get, right? It's the outcome. It's like what we call the end product of all of these different processes. Machine learning, if you like, is the process. It's like, how does the computer get to a state where we then call it an artificial intelligence? It does it by machine learning. And typically there's two main types of machine learning, to kind of use a crude way of putting it, but there's supervised machine learning, where basically we tell the computer, I want you to maximize, I want you to predict the outcome based on these different factors. And for every time that you predict it correctly, I'll give you a point. And every time you predict it incorrectly, I won't give you a point. And your objective is to get as many points as possible. That's essentially what supervised machine learning is. Unsupervised machine learning is a bit more complicated, and it's basically about finding patterns in data, but it's not really the coverage of this talk today. And large language models, or all the different techniques underneath, these are actually like, what is the computer actually doing? Like, what's the math? What is like the code, if you like, that's running to do this machine learning that produces an artificial intelligence? So a large language model, like the one that gives ChatGPT its ability to give us really smart answers when we give it prompts, is being determined by a large language model. So hopefully that made sense. Any questions there before we move on? I just want to make sure we're all on the same page here, or is that relatively clear? Okay, sounds like we're good, so we'll keep motoring. I think it's also important to point out that AIs come in very different shapes and sizes, right? So we saw in the chat that some people have the mental model of like ChatGPT is in AI, and it absolutely is. And it would fall into a category that I would call interactive prompt-based AIs, right? You have to come up with some sort of prompt. You have to ask it a question or give it a task in text and tell it what you want it to do. And then it attempts to do that, and it produces text output for you based on the instructions that you gave it. We also have things like recommender systems, right? So when you get these emails from Netflix where they're saying, hey, you're going to love this new movie with Kevin Hart in it, and we know that because we've taken all the data that we have about you and your watching patterns and compared it to millions of other people who are like you, who watch similar things, and they love this Kevin Hart movie, so we're recommending it to you. That's an AI that's doing that. It's a machine learning model that's doing that. Ryan, yeah, you're good.
I was just gonna say, did you block out just your name? Because we could infer that it probably says Karl. We might like. Is that like really compelling personal information there?
Yeah, it's top secret. It's top secret.
Anyways, well, now we know about your Kevin Hart thing. Carry on.
Just massive Kevin Hart fan, huge. And then the third type, I mean, there's much more than this, but just to give you another example, would be things like algorithmic pricing, right? So when Uber is doing any form of pricing, right, whether it's surge pricing or just how it determines the price in order to make sure that there's enough drivers on the road and that there's people who want to take those rides, that's determined by an AI, by a machine learning model, right? There's no human sitting changing the knobs and the dials to determine what the price should be. It's all determined algorithmically in the back end. And so they come in different shapes and sizes. This slide, I have to heavily caveat, right? What I'm going to attempt to do is give you some big picture ideas of what AIs can do well right now. And you saw some other examples in the last slide, right, of things they can do well. But I tried to create some like big buckets of new things that they're really starting to get really good at. But the caveat that I have to give you before we go through these is that the field is changing literally so quickly right now that this slide will probably be out of date in a couple of months. So literally this morning while I was eating my breakfast, I was scrolling through a newsletter that I read, and they were talking about Meta's new AI that's coming out in a couple of weeks. It's called Tool Transformer. And that AI is actually going to be even more advanced than all of these things I'm showing you. It's going to be able to make calls to other computer code, basically through APIs, to do things like if you ask it, say, so at the moment, AIs are really bad at doing simple math, right? So if you ask ChatGPT, for example, I have this math equation, solve the problem, it very often gets it wrong. This new model from Meta that's going to be coming out solves that problem by basically saying, you've asked me a math problem. I'm not good at math. I'll go to a calculator. I'll ask the calculator to fix that problem. That will give me the answer and I'll interpret that and then give it back to you as text output then later. So it's going to have the ability to kind of remotely access other modules through an API to answer more sophisticated questions. So like I said, literally this slide is going to be out of date almost in a couple of months, maybe even a couple of weeks time. But what they do really well right now, one example is they place really good realistic phone calls. So Google has an AI that it calls Duplex that's used for making reservations. So you just say like, oh, I want a reservation at my local bar for 7 o'clock this Friday for 2 people. Go and make that, please. The AI takes that information. It looks up the restaurant or the bar. It finds the phone number. It calls it. It then generates synthetic voice using an AI. And it holds a conversation. It listens to the response of the person on the other end of the phone, and then generates like realistic sounding prompts to say things like, oh, I'm looking to book a reservation for Friday at 7 o'clock at this particular bar, or whatever. And it will also do things like include like little hesitations. It will say, or yeah, that's right. To the point where when Google demoed this, the people who were taking the reservations had no idea they were talking to an AI. It was extremely convincing. The second thing they do really, really well right now is they write code, generate text, and summarize text. They're really good at these 3 things. So ChatGPT, if you've played with that, is a really good example of that. Actually, maybe just like hand up emojis in the chat or on Zoom. Who here has actually played with ChatGPT yet? See a few hands going up. Yep. Okay, a decent number of people. Okay, great. If you haven't, I'd really encourage you to do it. We'll take a quick look at it in a minute when I get to another slide. But really, it is impressive how well it's able to answer a bunch of questions on a wide range of topics. One thing I'll say, and I'll touch on this again later on, is that while it's very good at coding, and I do mean very good, it's still not perfect, and it will make mistakes from time to time and make them very confidently. And we'll talk about that in a little while. And then the third category is really around generating and identifying images. So this image that you're seeing is literally from a prompt that was create an avocado chair, right? An avocado chair is not probably a thing that really exists in the world, or at least if it is, it's not something I've seen in a lot of my friends' homes when I go to visit. More of a shame really than anything. I think more people should have avocado chairs. But an AI generated this image from scratch, right? It placed every pixel in order to determine, to take the input and say, okay, avocado and chair. What do I know about avocados? What do I know about chairs? And how can I realistically create a chair that looks like an avocado? And you'll notice that like when you look at this thing, it doesn't even look like incorrect from the sense of that looks like something you could sit on, right? It looks like it would actually work and function of a chair. And so AIs are really, when they learn from such large data sets, they get really good at being able to kind of replicate the important elements of an image or something like that and generate and identify these images. They're getting better at doing this for video. I think in a year's time, or maybe even 2 years' time, we're going to have AIs that you can prompt and they'll be able to basically create videos for you. But that's it's a little less good at that. Let's see, just check the chat here. What AI did you use to create the avocado chair? And that is an example from DALL-E, which is another OpenAI prompt. Okay, so let's make it a bit more concrete and about behavioral design, since that's what we're going to talk about. What parts of behavioral design can AIs do well right now? So they're really good at summarizing literature. And you'll note that I use the word summarize and not conduct a literature review. And that's intentional. If you ask ChatGPT in particular to basically create a literature review for you on a given topic, it sometimes will completely make up articles. As in, it will like say, oh, you know, G. Ryan and Purcell K 2020 on being totally awesome, or whatever the paper name would clearly be if Ryan and I had a paper. but that paper clearly doesn't exist, right? But it will create very compelling examples that you think are real, give you a summary of what that paper supposedly says, and then you'll Google it and realize actually that doesn't exist. And so what's better, I think, at the moment is to take large parts of a article that you're reading and copy and paste it into ChatGPT and ask it to summarize it. It does a really, really good job of that. There are other AI systems that are being developed at the moment that are getting better at actually conducting literature reviews and making sure it doesn't produce false results. But that'll be another couple of months before they're really refined.
Karl, I met with a team that had designed an AI tool for teachers this week, and they had said that the analogy they gave was AI is like a 5-year-old. It's going to make up stuff, and it's absolutely going to believe it's true. You know, and you'll have to question the 5-year-old a little bit, otherwise you'll be in big trouble.
Totally. And you'll, I have an example loaded up actually that we'll look at in a minute from ChatGPT where it does exactly that. Another thing that it is pretty good at is for like acting as a brainstorming partner, right? It's pretty good at, like, if you say, you know, I'm trying to think about ways that behavioral scientists could encourage people to stop smoking. Give me 10 different behavioral interventions that could reduce smoking. AIs like ChatGPT, or even AIs that have been trained on the behavioral science literature more specifically, will give you some pretty decent ideas. They won't be perfect though. And more importantly, they won't necessarily think through the implications or the so whats of those recommendations. I mean, you can always follow up and say, oh, what would that imply for policy and so on? But I would say it's really more of a brainstorming partner rather than here, it's just going to give you a solution that you can go ahead and implement straight away. And then the third thing that I think they're really useful for is acting as a coding partner. And again, this is some intentional language. So I was doing some analysis recently where I was analyzing the results of an experiment that we ran on Tinder to see if people or if women are more likely to respond to messages that are funny or that are messages that are earnest. And as I was doing it, I was asking ChatGPT different questions like, oh, I need to remove all duplicate data from this data set where this ID matches itself multiple times or whatever. Give me a piece of code to do that. ChatGPT was awesome. It gave me literally a piece of code that was good enough to copy and paste in, change 1 or 2 variable names, and boom, you could run it and it worked. When I asked it to do more complicated things, when I said, I'm considering running analysis to understand whether the difference in proportion between the response rates between this group and that group is statistically significant, give me some code to do that. It wasn't so good. It recommended the wrong statistical test with high confidence and was like, oh, you should totally use this chi-square analysis approach. And when I actually thought about that for a minute, I was like, that's completely wrong. That wouldn't be appropriate here for lots of different reasons. The statistical assumptions will be broken, but ChatGPT doesn't think through all of those things. It doesn't do that. It's literally just predicting token or word after word to give you some sort of response that seems likely. Okay, and so what parts of behavioral design do AI struggle with, or how are we going to all keep our jobs? It does struggle with some things very clearly. So one is experimental design, and let me just show you an example. This might be particularly interesting for people who actually haven't used ChatGPT yet. So what I did here was I just gave it a prompt, and I said, imagine you're a behavioral scientist and you want to run an experiment to measure whether female Tinder users are more likely to reply to humorous messages rather than earnest messages. Describe in detail how you conduct this experiment. Make sure you identify any potential confounds. Great. And you'll see here a super long and detailed response where it's going through like the 7 or 8 main steps of any experiment that you would have to do. When you start to pick apart parts of this though, it's not perfect, right? So it says like you want to control for some potential confounds. They might be things like age, education level, occupation, and relationship status. Great, that's a good start, but it didn't consider probably one of the most important ones, which would be location. So when we ran this study in actuality, we made sure that the profiles that we were using to send these messages were matched based on location, because people are much more likely to respond to people when they're nearby versus when they're far away. So it misses important variables that you should control for. If we look at this section on data collection here, it says, oh, you should ask people to, after receiving the message, to rate it on a Likert scale from 1 to not funny to very funny. We did that as part of a pre-test, but that's not how you would run an actual field experiment, right? It's unlikely that a load of Tinder users are going to take the time to rate the message and send it back to you and say, oh, I found that a 5 funny or a 1 not funny. In reality, what we did was we measured reply rates because that's a more objective behavioral outcome. And anyway, this is just to make the point that, look at this, right? It's a pretty convincing answer. It's written very nicely. It has got some things correctly, or has identified some elements correctly, but it misses a lot. And so just to say, AIs do struggle with things like considering the full implications of experimental design. They can create behavior maps. And the reason for that is AIs, at least at the moment, are not good at integrating information from multiple sources. So if you think about it, a behavioral map, right, is taking some sort of process, like imagine you're trying to encourage people to buy LinkedIn Premium, for example, and you're thinking through every step someone would have to go through to complete that. You might have to integrate information from lots of different sources to do that. You might have to think, what email do they get that encourages them to sign up? And when they click on that email, where does it go? And what's the sign-up process actually like? What's the person thinking about when they're going through that sign-up process? Are they likely under a lot of cognitive strain or not? You know, et cetera, et cetera, et cetera. AIs are not good at thinking through all of those different elements and can't integrate information across sources in a way that humans can. And so they struggle with doing things like creating behavior maps. And for similar reasons, but also for technical reasons, they also can't diagnose user interfaces. So a lot of the work that we do at Irrational Labs is taking a product or a service and how it's presented and literally looking at what does the design imply for the particular behavior we're trying to encourage or discourage? Is it working with us here or working against us? And AIs, for the most part, are text-based at the moment. Most of the prompts are text-based. There's no AI that I've seen where you can kind of upload a bunch of HTML or images from a website and say, diagnose what's wrong with this. Maybe in a couple of years that'll be possible, but certainly at the moment, it's not. And then the other thing that they struggle with is fully designing solutions. So like I said, they're a good brainstorming partner for coming up with solutions, but they struggle to think through all of the details of an implementation and actually like, how exactly would I apply social proof in this particular context? Let me just check the chat real quick before we move on. Yeah, okay, great. And there will be time for questions at the end. So now let's deliver on the promise of this talk, right? And talk about 3 ways that I think AI is going to change behavioral design, informed by what we just talked about what it's good at and what it's not good at. So I think AI is going to change what behavioral scientists do and how we do it. And it's going to do it in 3 main ways. I think the first one is it's going to make stuff that's at the moment cost prohibitive. I think it's going to make those much more affordable. And that's going to mean that they're going to be scalable. And that's going to change the type of interventions that we can recommend to solve behavior change problems. I think it's going to simplify a lot of the complex and tedious tasks that we do, like creating literature reviews, for example. And then thirdly, I think it's going to help us get even better at targeting our interventions to make sure that we're getting the maximum impact whenever we're designing a behavior change intervention. So let's quickly look at each of those in turn. So imagine, right, that you've spent a couple of months designing a new program that brings top coders into low-income areas to help struggling students. And awesome, you run the experiment and you find, oh my God, it works, it's super effective. This is amazing. We should scale this to every low-income area in the country. What might make it hard to scale an intervention like that? Let's see some responses in the chat. Why might it be hard to scale a program where we bring top coders to low-income areas to help struggling students? Number and availability of top coders, absolutely. Any other ideas? Internet access, yep, could be. Cost, absolutely. Top coders are only in some parts of the country, absolutely. The barriers might be different, yep, that's also fair. Location, COVID, network speed, all absolutely good ideas here. I think some of them you absolutely nailed. There are exactly these problems, right? We have a limited supply of great coders. There's only so many coders who we would say are in the top 10%, right? And similarly, they're likely to cost a lot. And not only that, if we start hiring them at higher and higher rates in order to scale our program, their salaries are only going to start to go up and up as they become even more in demand, right? And similarly, even if the top 10% coders are great, the ones that we had in our program might have been particularly good at teaching, for example. And so it's hard to train all of our coders to be equally effective at training in the way that our program delivered this particular intervention. And so AI changes a lot of these things. AI-powered instruction software scales much more easily. And the reason that AI is going to be a game changer in areas like this is that the marginal cost of deploying an AI educational tool is tiny, right? Hiring that next teacher is going to get more and more expensive. Deploying an extra instance of the AI basically costs nothing. If the person already has a device, it's the cost of them opening another website. And similarly, you'll have no or little to variation in teaching quality, right? When we teach the AI, or sorry, when we program the, or when we train the AI, should I say, in order to do this effectively, and we replicate and we show in an experiment that it actually is effective at teaching, we can then say with high confidence that this thing is going to be just as good at teaching the next person and the next person, and that we don't need to worry about the fact that, you know, some people or some coders are better at teaching than others. Just check the chat real quick. Yeah, exactly. No noise or justified variation. Absolutely. And so I think what this implies is that some of the first wave of where we're going to see these particularly text-based AIs being deployed, I think is going to be in providing support, like customer support, and also in coaching interventions. And so let's take the coaching one first. So this example over here on the right, Rocky AI, is a motivational coach that helps you kind of stay on track when you're feeling like you're low on motivation. So you can say like, you know, I'm really struggling today to go on this run, or I'm really struggling to do that work task that I had. Give me some ideas for increasing my motivation. And Rocky will come back and say, you know, have you tried goal setting, or it might give you a motivational quote, or it might do something else. But more generally, I think we're going to see this approach applying in lots of different industries. You could imagine in the fintech industry that it's hard to give every single American a financial advisor, right? Someone who's going to coach them through all their financial decisions. But it might be possible soon to have a really smart AI who's really good at giving financial advice and have that scale to everyone. And now suddenly everyone has a personalized financial coach. So it's going to be really interesting to see how all of these different coaching interventions really change as AI comes into the fold and makes this much more scalable, much more cost effective for a wide range of applications. If we think about customer support, we're also going to see this proliferate, I think, in this case, because if you think about it, most businesses treat customer support as a cost center, right? It's something they ultimately have to do, but that they want to minimize the cost of. And so someone rightly pointed out earlier on about the efficiency of having an AI solve certain problems. And I think this is a case where that will definitely apply. And so what you're going to see is you're going to see AIs like Poly AI, which is a customer support chatbot, and it's capable of doing two main things. So it can basically take all the inputs that someone's giving it, right? This customer is saying, I lost my card last Friday, and now there's an 87 charge that I don't recognize. Can you help me with that? It's doing two things. First of all, it's pulling out key data, right? It's saying, lost my card. That fits under the use case of lost card. So now it knows to already start thinking about what's the process that we follow when a customer has lost their card and we need to fix that issue. And you can see that it can generate like human-like responses. It can be empathetic and say, okay, I can help you with that. I just need to confirm your details. And it will be able to kind of bounce back and forth as the customer gives additional details and so on. So I think this is going to be a real area that we're going to see just kind of rocket in the coming months. The second one, we're going to skip over a little bit because we covered a lot of it already, but really it's just to say AIs are going to get really good for simplifying complex and tedious tasks like summarizing literature, brainstorming solutions, or things like coding where we don't want to have to do a load of Googling and using Stack Overflow. And then the third one, this is where I think AI and machine learning are going to add a huge amount of value to what behavioral scientists already do. So we're already good at running experiments to check whether a particular intervention changes a behavior in the way that we want, right? And measuring just how effective that is. But one thing that we probably need to get a little bit better at is how do we make sure we target that to the right people at the right time to maximize the amount of behavior change we get? And so let me talk you through a concrete example here. So I'm sure a lot of you have heard of this example before, right? These O-power social normative comparisons, where if you show people how their energy use compares to their neighbors, and particularly their efficient neighbors, people are likely to say, oh, I'm using a bit too much energy, I should change mine. And we usually see energy use in and around a reduction of 2% when we use this intervention, right? When we roll this out across a large population of people, we see that on average, people reduce their energy use by about 2%. Okay, that's good, but can we do better than that, right? We start thinking about, well, are there more clever ways to target this intervention, right? So if we think about, what about the people who get these comparisons who are already using less energy than their neighbors? Then they get a message basically telling them, hey, you use way less energy than your neighbors. Some people might think, oh, really? That means I can kind of afford to splurge a little. I can maybe increase the amount that I use. And maybe that's making a few people increase their energy use and dragging down that average saving figure that we're seeing. You might also think that different households might respond totally differently, right? A high income house that's with a lot of what's the word I'm looking for? With a lot of extra cash, and who live in a large home, who have a high baseline energy use, they might change their energy use a lot more when they get a message like this, compared to a household that's already using as little energy as it probably can. And so if we use AI or machine learning techniques as part of our experimental setup, we're actually able to understand and dig into the data and say, okay, well, for which subgroups is this most effective? Like, who really changes their energy use, and who actually does this backfire for? Who starts increasing their energy use? And a study by Nittel et al. Did exactly this. And what they found was, if you use a machine learning algorithm to find the people who are most likely to respond positively and the people who are most likely to respond negatively, and then instead change who you're targeting in terms of who you're sending those social nudge comparisons to, you actually get social benefits of between 12 and 120%. You increase the benefits that are coming from this experiment by a huge amount. And if you look at this graph on the right, it's basically telling you where this is coming from. So where it's in the positive, so where it's leaning to the right side of the graph, they're people who we should be sending more of these messages to, because they are going to change their energy use more. And the people where the bars are on the left, or the factors that are pointing to the left, they're the type of things where we want to avoid sending these type of comparisons to those type of homes. So what you can see basically from this data is that if we send these type of nudges to larger homes in higher income areas who have higher baseline energy use in the first place, we see a lot more savings. And we could probably argue that's probably more fair too, right? These are the people who could probably afford to cut down on their energy use a bit more. And so I think roll on a couple more years and we get to a point where we're able to take a data set from an experiment that we ran, right? And we say, oh, we experimentally manipulated whether people got this particular behavior change intervention or that one. We upload all of the data into an AI system. It performs a set of analysis and says, oh, actually, you should target your next rollout to these specific groups. I really don't think we're that far away from a tool like that. Okay, then before we talk about ethics, let me give you a little bonus here and talk about changing our own behavior. There was a really nice paper about a year ago, or 2 years ago now. Oh my God, it's 3 years ago. What has happened to time? In the Journal of Behavioral Public Policy. It's about self-nudging. And this is the idea that, like, we all know ourselves the best, right? We all know what behaviors we're trying to change. Like, maybe I want to run more, maybe I want to eat a little less, maybe I want to save a little more, but we know ourselves the best. And this paper makes the argument that, summarizing this quote on the left, that we all have these kind of little tricks that we play on ourselves to try and change our own behavior, right? So have you ever done something like set out your clothes on your bed so that when you wake up in the morning, your running clothes are right there and you're more likely to go out for a run? Or have you ever like taken a letter that you need to send that day and leave it balancing on the front door on the handle so that you have to bring it with you when you leave? These are like kind of mini examples of self nudges, right? They're little behavior change interventions that we set up for ourselves to try and improve our own behavior. Well, what I think AI is going to make super different and super interesting real soon is that we're going to have really powerful personal assistants in our pocket, in our smartphone, that are going to be able to help us design really clever and sophisticated behavior change interventions to help us stick to our own personal behavior change plans. And let me talk you through a concrete example that I don't think is unlikely to happen in the next little while. I think this is more than plausible in the next couple of years. Imagine asking your smartphone, right, that you want to avoid your local ice cream store to help you stick to your diet. This is a problem I have. We live not too far from a really delicious creamery, and I walk past it and I just really can't help myself, right? I'm an Irish guy in San Diego, the sun is out. I just cannot resist the idea of kind of just getting a nice ice cream and walking around in the sun. But it's harming my diet a little bit. Maybe I want to cut down on how often I'm doing that. So I tell the AI about my problem. I say, you know, there's this lovely creamery down the road. I'm always walking past it, and every time I walk in, I just can't resist the smells of the ice cream and the way that it looks in the window. And I go in and I'm failing to meet my goal. And I say, AI, give me some ideas for how I might change my behavior and not fall prey to this. Okay, so then the AI would spit out a bunch of recommendations, right? It might say, you know what you should do is just stop taking that route past the creamery, right? And maybe that's not possible. Maybe there is no alternative route. I go through all the suggestions and eventually I find one that I like, right? It says, hey, why don't you set up a geofence so that every time you walk by that store, your phone will automatically donate to a charity that you absolutely hate, right? That you really just do not want to be supporting. And I say, actually, I think that might work. You know, I could think of a charity that I really disliked. And I think if every time I went near that store, there was a donation made in my name to that charity, that would change my behavior. Okay, AI, go and set that up. And then the AI would literally do everything that was needed to set that up. It would write the pieces of code that would create a geo fence around the store so that when my GPS sensor on my phone gets too close, it would trigger a wire transfer that would go from my bank account to the charity's bank account, and then send me a reminder text message to say, by the way, Carl, we just donated $50 in your name to that charity that you hate. Remember, you're trying to change your behavior. And then you sit back and you marvel and you say, oh man, if I did that twice, right, in a week and made that mistake and donated to that charity that I really dislike and I have that visceral reaction, my behavior starts to change over time. Something like this, right, and this is kind of a funny example, but you can imagine more practical examples where you're trying to do things like set up saving habits or whatever. This type of stuff is going to be possible within the next couple of years, no doubt. And so we're going to be able to nudge ourselves in a way that was previously not possible. All right, let's quickly touch on the responsible use of AI and ethics, and then we'll have a good amount of time for some lively questions, hopefully. The first thing I want to say here, and if you don't take anything else away from this talk, just take this away. AI is not perfect. It is not currently all-knowing, omnipotent, perfectly accurate. It makes mistakes a lot of the time. So it can be inaccurate. When we ask AIs like ChatGPT to give us recommendations for what we do, or give us the answer to a particular question, it is just predicting text tokens. It's just trying to predict something that is likely a good response. It doesn't necessarily know whether that answer is right or wrong. That will probably change in the next iteration. Maybe we'll see a model that's better at this, but always there's going to be some element of inaccuracy. There's always going to be parts of where the AI is going to fail, in the same way that a human would, right? Humans don't know everything either. But it's important to think about, particularly if you're going to think about using AI in an intervention space like health or law, right, where you're giving legal advice, the consequences of giving incorrect advice in those areas is very, very high. So maybe AI is not a good idea to implement there straight away. Maybe it needs a lot more research. We need to be a lot more confident that it's at least not making as many, or it's at least not making more mistakes than a human would make under a given set of conditions. So the first thing to consider is accuracy. The second is bias, right? So depending on how an AI is trained, depending on the inputs that are given to it, depending on the reward mechanisms that are set up when it's training, depending on the data sets that it's ingesting to learn about the world, it can learn biased things. It can learn to treat different groups differently. It can just completely ignore certain parts of the world or how they operate and behave. So certain AIs that you see that are trained on large data sets that are generated by Western universities and pulled from scraping the English-speaking internet, for example. So we're missing a lot of cultural context. We're missing a lot of understanding of how different people behave in different countries and all of these things. So AIs can be biased, and that's important to take into consideration. And then the last thing I'll say that you really want to consider is this idea around disclosure. I personally think, and we can have a debate about this, that consumers should be aware when they're interacting with an AI, in particular when it's something that is pretending to be human. So when it's a chatbot, when it's a phone call that we're placing, or soon when it's like a video call that we're having back and forth and there's an avatar on the screen or something. I think it's important to make clear that that is an AI that you're talking to and not a human, and particularly in areas like mental health. So there's a company that I won't name who had a Twitter post recently, and they had run an experiment where they had an AI generating potential responses that their agents could give to people who were seeking mental health advice. Now, if you think about that even for just a second, right? Imagine you're someone who's going through a mental health issue. You finally built up the courage and you say, you know, I'm going to reach out and talk to someone to get the support that I need. And then you find out that you're talking to an AI. You can imagine the impact that might have on your mental health or on your willingness to reach out for support in the future. And so I think, particularly in sensitive use cases like mental health and other areas like that, we really need to be clear and upfront that, hey, this is an AI you're talking to, not a human. It might be okay to have an AI deal with my banking issue, maybe not so with my mental health issue. Okay, and with that, hopefully it'll be like this scene of 300 and the questions will just rain down and we'll have a good, lively discussion. So yeah, feel free to either pop questions in the chat and we can moderate, or if you want to come off and ask them on the mic, that's fine too.
Yeah, Karl, actually, there were a couple questions here in the queue. So let me get to those folks. And actually, I think this is a great jump. G Kim, are you still there?
Yeah, I'm here.
Awesome. So your question was about couples therapy. You want to elaborate on that?
Well, yeah, I mean, me and my wife use couples therapy, and one of the things about couples therapy, as you guys could probably all guess, is like not all healthcare, like provides that as part of their benefits, and hard to find good one, and cost is very high, and also like So I'm wondering if AI could potentially replace that. But what like you guys just said, you have to be watch out for the. It's not very good with mental stuff currently, but I don't know. It's getting smarter, but I wonder if that's like the new trend. Is it possible that AI might actually supplement or replace couples therapy?
I think it's possible. Yeah, I think, given enough training data, it could learn to identify what type of questions it should be asking, given on the type of things that you're talking about. I think whether that would be as effective as a human therapist, I don't know. And you'd probably want to run an experiment to test that. You can imagine, right, that there are many things that a human does in couples therapy, a human therapist, I mean, and that an AI can't simulate. So body language that they're giving off as you're talking, and being able to interject and kind of, say, hey, hold on, you need to listen to the other person, whatever it might be. But I don't think it's outside the realms of possibility that at some point we'll see chat-based mental health support, couples therapy support, all of these things. I just think it's important to, if we're going to do things like that, that we're super clear and transparent with people that, hey, this is an AI that you're using, not a human.
Awesome. Did that help, Jai?
Yeah.
Cool. Evan, your question was next. You want to take the mic? Oh, there we are. Cool. You're there. Go ahead, Evan.
Yep, I'm here. I forget what question I asked.
You asked
to go back in the chat.
Yeah, what situations do you think conversational bots are helpful versus when traditional GUIs are better?
Yeah, like, if you're like, I work at an e-commerce company. And if you're trying to, I don't know, treat the flu, there's ways of doing that with a bot. An AI could be interfacing with you and route you to the right next thing, or there could be a traditional interface for that. So when you're thinking through the different trade-offs of that, just wondering where that lands, where AI might be appropriate and when traditional user interfaces.
Yeah, absolutely. So I think when you've got like a really clear structured process and that, let's say 90% or more people are going to follow, if they fall into that bucket, that's when you want like a traditional GUI approach and you're just like, okay, I can click through the options and get there, that's fine. I think when you've got a lot of variation in what the customer wants or needs, or what they're looking for, then you might consider a chatbot, like an AI-powered chatbot. The other thing you might consider is, how is the customer feeling, right? Like, is this an area where they need, they need a lot of like empathetic support as they move through this process? That might be better for an AI. And as well, some of it is around what type of data are you collecting. So I did give you that example of Poly AI that can kind of pull key data out, right? Like as it interacts with a human, but a general user interface, obviously, it makes it much clearer what the human needs to enter, right? So for example, I doubt we're going to see chatbots asking people for credit card information for lots of different reasons. One, because of trust, but two, because it's just easier to have a box that says there's 16 digits in your credit card and enter them all here. So I think it'll depend on the use case. It'll depend on like how much variability there is, depend on things like trust and whether the level of empathy that needs to be provided as you're solving the problem.
Is that helpful, Evan?
Yeah, thank you.
Cool. So we don't have a ton of time left. So the lineup here is Andrew, David, Rajesh, and Shazali. I'm saying your name wrong because I always do. I'm so sorry. But Andrew, go ahead, take the mic.
Yeah, so I'd like to ask some questions in regards to nudging. Do you think there could be significant cognitive overload?
Sorry, Andrew, you broke up a lot there.
Can you hear me now?
Yeah.
So my question was in regards to cognitive overload as it relates to the nudges.
Yeah.
So do you think that there could be significant cognitive overload given the pre-commitment through AI? And how do we navigate around that?
So do you mean that like having to basically come up with the questions that you need to ask the AI in the first place to get it to do stuff is going to add extra cognitive load to a process rather than less?
Yeah, like, I mean, if you say, hey, I want to diet, I want to do all these different things and to improve my life, and then it's like nonstop barrage of it.
Okay, I see what you mean. Yeah, I mean, I think that's like whether an AI is designing your behavior change intervention, whether you're doing it, whether someone else is doing it, there's all these things to take into consideration, right? So like, imagine we're sending text messages for motivational support for job seekers. Do you want to have an AI that's sending one every 10 minutes? Probably not, right? That's going to feel like, please leave me alone. That's just like way too much text messages, too much information. And so part of it will be like, you'll note that the example, the silly example I gave, right, with the ice cream store, one part of that is that the human still needs to review it in the loop somewhere and say, that behavior change intervention, I'll pick that one that you propose because that makes sense for XYZ reason. I don't think we're going to be in a position where we describe a problem to an AI and we go, okay, so you come up with ideas, you code it and you launch it. I think you're going to need a human in the loop to make sure that things make sense and that we're not doing things like barraging people with information.
Thank you, Carl. That was great. David, you want to take the mic?
Yeah. Hi, Carl. Can you hear me?
I can. Hi, David.
Hi. Yeah, so right now, ChatGPT uses information on the internet to generate its answers, right? It's summarizing information on the internet. And right now, most of the information on the internet is human generated. But presumably that will change over time. Like I saw a statistic the other day that by 2030, 80% of the information on the internet will be AI generated. Does that mean the answers that things like ChatGPT gives will degrade over time because it will be summarizing information that's summarized in turn by, you understand what I mean? Like it's going to be like a ever decreasing circles kind of thing.
Yeah. I don't know, being like completely transparent, I genuinely don't know. I mean, there's probably a couple of reasons that you could push back against that type of thinking. So OpenAI who developed ChatGPT have already acknowledged that this is going to be a problem and have come up with a method for basically watermarking AI generated outputs. And so that would basically mean that imagine you have a model that's continuously learning from the internet, right? Just pulling and learning, but you don't want it to learn from stuff that's been generated by other AIs. This watermarking technique would allow the AI to say, oh, that's actually not created by a human, that's AI stuff. I don't care about that. Throw that out of the data set. Don't learn from that. Give me more human stuff, learn from that. So that's one thing. And then it really depends on how they're trained as well. So like, I don't know whether it's likely we're going to have an AI that is like always on, always in training mode, just like scraping, updating, getting better, scraping, updating, getting better. At the moment, the process seems to be a lot more like, there's a large effort to scrape and gather and combine information sources, clean that information, make sure that it doesn't contain things like, you know, hate speech or wherever else, or try and remove it if it does, and then train the AI on that. And so again, that's kind of like a little bit of like a human in the loop process that would be able to maybe mitigate against some of that. But it's a good question. I think it's possible. Whether it happens will probably depend on lots of different factors. I think it's hard to predict whether that's going to happen or not, but there are some reasons to think why it might not.
Right. Thanks.
Furthermore, if next week next week we do have an event, and if I'm just an augmentation of old prior recordings of me and I just switch outfits, you'll know. But let's see. So Rajesh.
Hey, Karl, can you hear me?
I can. Hi.
Hey, thank you so much for this wonderful presentation.
Great.
My question is of two parts. With the growth of ChatGPT-3, I believe that people will trade accuracy for fluency. So is it even proof? So will people trade accuracy for fluencies for the first part of the question? Second thing is, assuming if it's true, we're going to have more content developers that are going to be there. More content is going to get generated. What would be our filtering mechanism as we move into the future?
So are you saying that people are going to start valuing accuracy more than just...
No,
like
it's more fluent, right? It just gives you a confident answer. So
yes.
people are going to, rather you'll see people taking more of looking into ChatGPT or Google or other things like that, because it's just fluent. So I see, while we know that it's going to give incorrect answers, people rationalize it because it's very fluent is one theory that I have.
Yeah, sure.
Yeah, and the second thing is, if this is true, it's taking the writer's block of people. So you, instead of more content consumers, you're going to see more content creators that's going to be there. As it is on LinkedIn, we see a lot of posts around just even playing with ChatGPT-3 as a post there. So what will be our filtering mechanism? Is it going to be burdened heavily as consumers of content?
Yeah, that's a great point. This is a massive issue, right? I think it's also related to issues around like misinformation and things like that, right? So like we're going to have situations where we're going to be able to, instead of having, you know, essentially a bunch of people sitting down writing a lot of misinformation content and spreading it around, we're going to have AIs doing it. How are we going to fight that? Open question. I think it goes back to some of the things around like watermarks and stuff, and trying to being able to have reliable ways of detecting AI generated content and flagging that it is. So that's why I think disclosure is so important. And then the kind of confidence versus accuracy trade-off. I think we're going to see that problem resolved maybe even in ChatGPT-4. There's some rumors going around on Twitter and stuff around that ChatGPT-4 will be able to kind of self-assess and say like, I'm 70% confident in this answer. I have no idea what it's going to actually look like. They haven't announced that yet, but I would imagine either in this next release or in a release after that, we're going to have models kind of give meta commentary and say, right, here's my answer, but I'm only XYZ confident because of XYZ reason. So I think, and then obviously, right, it kind of depends who wins out in terms of what becomes the, like, great, if OpenAI are going to take ethical responsibilities on board like that and build this into their models and they win, great. But if bad actors develop really good AI models and they don't build those things in, then we could have problems for sure.
Yeah. Thank you. Thanks, Karl.
Yeah, thank you so much. So we do have to wrap at this juncture. So Shaliza, I owe you first question next event, I promise. I will leave you with a comedy note. I was at this Ed Tech conference this week, and technically in the state of Illinois where I am, right, ChatGPT is illegal. Like, it doesn't have the student privacy protection. So if you're using it in a school, it's problematic. However, kids are, and hysterically, the kids are learning how to do the AI interface, and they're writing like write a 6th grade level paper on topic Y. But all the teachers know, because that kid's writing at a 3rd grade level for real. So like, you used a lot of big vocab words. So, you know, our brains are still useful. Karl, that was spectacular. I haven't been on this call in particular. It felt like I was sitting with a fortune teller because you were really trying to look into the crystal ball, see the future. But what was so impressive was the way that you delineated your thinking, and you kind of already categorized these areas of concern and tension moving forward. I think it was absolutely brilliant. Thank you so much for your energy. Thank you everybody for coming to Kick It on a Friday. We hope we will see you next week for our next open event. And you know, go forth, have an incredible weekend. Karl, any closing thoughts?
Yeah, play around with ChatGPT if you haven't, will be my big takeaway. And thank you very much for your attention and the excellent questions.
Yeah, take care, everybody. Have a wonderful weekend. We'll see you back at Irrational Labs HQ